implementing in our organization is in 2024, we started first with the test case generation. That was literally one of the slow moving tasks within the QA. So we kind of automated that with a 40% increase in our productivity. So that helped us to move forward. And, the agent at that point, it was not as heavily agentic at that point, I would say, or I wasn't aware, either one. But down the lane right now, the way Cloud Cowork works or the Copilot GitHub, and it's everything is so quick and fast. And we said, why not start building agents for our SDLC? The whole idea was based on certain issues that happened at the organizations where due to the recent layoffs and all, we still had to keep up the delivery times. Cost was going up. We have to reduce our QA department financial cost too. So all this led to us to actually start thinking from efficiency perspective, and that's how we started building the agents. It was not the hype or anything because we're a very mid-sized organization. QA footprint is really small. So ROI versus is it really worth getting into all this? But today I would say definitely yes. So let me start off with just showing you the framework. Sorry. Yes. So this is our layers of all the agents that we have. I'll walk you through how we are transforming from traditional testing into the agent-based system. As you all know, I don't have to go through the end-to-end of SDLC process. So I'll just jump how we have leveraged each and every stage of our SDLC and how the agents have been set up against that. What is driving all the agents, and how this is going to be helping us, and where human in loop comes into place within this framework over here. And again, guys, this framework is not like you're changing what you have today. If you guys are having like data driven, or you guys having had a POM, or it's just a hybrid version, this goes on top of it. So you don't have to change anything in your framework from the automation perspective. Think this as this moving from manual QA execution to more orchestra driven. So the first stage over here is the input and ingestion agent. What does this agent do is it reads raw PBIs, including, sorry, if I'm using PBI, it's a user story if you're in Jira. And this framework that we have can integrate with anything. I mean, you guys just develop and you can call your Jira APIs into this, or if you're using Azure DevOps, then you can get those API keys of Azure DevOps and insert in this, and this should work. So if you're building those agents, and that's how it should. So the requirements come from Azure DevOps for us. We got the raw data, which is more unstructured in some cases and structured. So it includes the descriptions, acceptance criteria, and in some cases we got the comments also from the PBI. The reason is, there's a lot of discussions going back and forth, and we do have requirements within the comment section. So we kind of wanted to capture those things both because those were some of the key things in our organizations. Sometimes they forget to go and update their acceptance criteria or descriptions based on the discussion. So we just wanted to have a full picture over there. Then the PBI skill indexer ensures that this information is stored in the centralized knowledge base. When I say centralized knowledge base, we do have a skill MD or a context, which I will talk about in the next slide. So instead of each team interpreting requirements differently, we now have a single standard source of truth. Like, everybody has a style of writing, how they want to. And sometimes when new people come in, they find that, oh, these are not good quality, let's rewrite it. I've seen that throughout my journey because everybody are very particular on certain things and all. But in this case, once we go through the agents, it's the same standard, same way of writing things and all. So the input to the next stage is easier. So we talked about, so what is the input, the PBIs, the domain context over here? What is the output? So what happens here is the agent goes analyze. So how when a manual tester goes in and reviews your PBI, then it comes back and say, hey, we need on this, or we need an update over here, or this is missing, we haven't thought about this. So the agent actually read the context, read the PBI. When I say the context, it is the domain specific context where you give what the application does. So you're giving the domain specific knowledge for the LLM. So at this point, then it goes in, the output would be more business rules and, structured functional requirements with clarifications and a document, MD, or if you're using Visual Studio, then it's a MD document, or you can actually integrate that with your SharePoint and send out a PDF or whatever format you want. So in this case, we had everything in Visual Studio as a phase one. So we have phase two and phase three also moving forward. So those are the clarifications that it comes up, which in turn, manual testers take that, review it, and then they go back during our sprint session to discuss about it. The next, um, the next layer is the skill. This is more governance. There is nothing happening here, but it just provides, unlike the other where each agent has an action, but this is trying to tell what the agent's knowledge base basically is within this layer. It defines how working scenarios should be written, or how page objects should be structured, or how step definition should behave. And gherkin and step definition, this is a concept of BDD. The reason, again, we don't follow BDD in our organization, but the small snippets of these, that BDD framework helped us to have a lot of clarity when we're discussing with the business or the because we have multiple business layers over here. So when we communicate to them and share what we are doing, or we have the use cases made more sense to them and to understand the coverage or what we're testing and all, rather than our traditional test case writing, click here, click there, and all. So that was the reason why we combined a small snippets of BDD with our POM framework for our automation. So that's how we kept that framework intact actually for this approach. And also the step definitions based off on the test, how to get those step definitions, what needs to be. So those guidelines or standards have been inserted in SkillMD, which actually gives as an input for the layers across all the agents actually. So why did we take this approach is like, because if we are hard coding the logic into each agent, so it's difficult when we have to update the same logic across. It's the same thing how we actually standardize minimum maintenance, robustness, and all. So the biggest advantage is that we can change the convention like locator strategy or a naming standard. We update it in one place and every agent automatically follows the new rules. So we don't have to define in every agent. So that's the skill layer. The next one is the page object model management agent. This is where building of the foundation of automation starts over here. The page object, it actually when you get into from the analysis stage into this POM management stage. 1 minute, sorry, this has to go. Yeah. Sorry, this is the one where test planner plus process analyzer comes in. So what this does is it takes the analysis. Once it is updated, it again go back and get the PBI information, and it breaks the requirements into test cases. Or in this case, it is the gherkin scenarios, and which are grouped by the business capabilities. So then this process analyzer goes a bit deeper. It identified the user flows, the navigation part, and most importantly, it goes in and actually understand the page object structure and see what is needed. And it clearly distinguish what to test and how to implement it. And that's what the output generally is, like the test plan and the flow description along with the page object model analysis report. That is the input for our next stage. And that's where we go for the POM management that happens. Okay. This is where our page object model is explored. It actually uses Playwright. Again, we just took the traditional Playwright. We did not use any agents that comes with the MCP, especially nothing, because we have our own agents built. So we didn't use, and moreover, it when we use those agents, it has its own prompts, right? So updating there and updating our agents was getting too much of a redundant. So to just make sure it makes easy, we just build our own agent at this level. So it then in this stage this agent it actually uses Playwright to create usable page objects. If it is already existing, then it skips, but if it is not, then it goes and creates those pages. It follows the strict conversions for the locators and the structures, ensuring that there is a consistency and all. So and also making this maintainable and scalable over time. So again, and as an output, we have the page object files over here and the UI interaction methods that are captured. The next stage is the test. This is the heart of it, where actually the script is being built. And this is where we had most of our time spent to ensure that the script quality and everything is. So the test automator takes the test plan, the prompts, and the generated automation in one pass, include feature files and step definitions also as part of the input. So there are like multiple agents that run simultaneously for this agent to actually work. So instead of writing script manually, now the it generates the production ready test suits automatically. Now, how is all of this being done? This is the orchestra. This is where all our agents are actually residing, and this help us to this agent actually controls the entire workflow through structured phases. Like this actually tells what and when each step needs to be executed in a sequential order, or it's going to be a parallel order. Then how the what should be the input for it, what should the output need to be. So everything is actually driven by the orchestra. And if some people might think the orchestra is one, but LangChain is also a kind of acts like an orchestra, which we did not implement here, but that's going to be the second phase. And I'll give you the reasoning why we did not take LangChain at this point. It ensures that then, uh, what else can I say? Okay, the task reviewer over here. So the task reviewer ensures the coverage. It makes sure all the test cases that or the scenarios that have been generated, the coverage is done. The quality is adhered, and it's actually following the skill MD guidelines that has been, and it's actually a kind of a governance layer over the automation, and it's not just a generator over here. So that's the role of this agent over here. The final one is the execution and delivery agent. This is the final step, which generates where Playwright actually is triggered over here. It runs the test cases through multiple stages, function, uploads, approvals, workflows, and more, and automatically capture the reports and log. And this is where we close the loop within our SDLC. So this is the phase one. We almost done with the execution. So we are actually deployed it across the projects and they're working. This is the stage one. The stage two is mainly where we are actually trying to see how to optimize our LML tokens and all. That is why, because it is hitting our cost or the
I'm the next one. So, yeah, I want to.
Is there a question?
I think I'll mute. If you're not speaking, can you please mute yourself, folks? We're getting some disturbances. Okay, I'm muting people who are not speaking. Okay, I think we should be good.
Okay, thank you. So I thought my last over here. Yeah, the phase two is basically optimizing the cost with the LLMs at this point. Oh, and across the different agents, we're not using one LLM model. It depends on, so for example, the test generator agent, we use Claude Sonnet or Opus, depending on the complexity of it, because we had a better quality over there. But when it comes to test case generation or for the working scenario, then we can just go to GPT-4 or 5, depending on what. So this way, this is one way of optimizing our costs. Now comes how can we actually even reduce the cost? Because if per month, if we are running around 10,000 test cases, that is the number of tokens cost goes up. So because it probably you might be spending about 2,000 or or 10,000 or 15,000 it depends on your runs and how the LLMs are breaking the tokens and the cost associated. So that is one thing that's as a next step we need to do. And also right now this is all in VS Code, like the documents or all. There's no traceability back to ADO, which is another one that we are planning to do as its phase 2. These are all cosmetic ones actually. And the bugs also we find, and then manually we're filing it at this point, but then we want that to automate itself, and then ADO needs to update and also trigger. And one more thing we're planning in this is actually when we have the stages in our workflow, right? Like, development, QA and stuff. So at particular stage, one of the agents need to trigger. For example, we have a customized workflow over there. So let me, for in generalized purpose, let's say sprint planning is going on where we are reviewing all the PBIs or user stories. In that case, it should trigger a day before itself once the product manager, product BAs, whoever is moving that from sprint from their new status or business readiness or whatever to the sprint planning status. It should trigger initiative for it to actually run the initial agent that we were talking about, the analysis one. So that will trigger and give us an output. We read it and we go into the meeting. So it will make us our lives easier and stuff and all. So, and then when we are ready for development is done and QA, then it should trigger for the execution. Bugs, once it moves into QA, it should trigger the bug agent for it to run. So these are the cosmetic things that we still need to do, which we are planning for phase 2. And the phase 3 is basically, right now it's all into Visual Studio. So you need to understand how to work with Visual Studio, how these agents, if something fails, how to debug. There's a lot of that goes on over here, right? So what we're doing is for the non-technical people and automation or manual testers, we are planning to develop an app, which already we did. It's a POC is done, and we just need to integrate this with that app and only display the results over there. And there's another option over there is to run our each agent too within that application. So instead of going to Visual Studio, looking at the empty files, we go onto the app and look at all the test cases and say, okay, approve. And then it goes to the next stage and runs it. And all the output files that we have talked about through all through the agents will display them on the application itself for us to review and for the next action item to be taken. And we are satisfied, then there is another button for that says, okay, go to the next agent. So that is the whole idea that I have, at least from the phase 3 perspective. So that ends what we have.
Okay, we have a few questions in chat, and I think right now we'll just start the discussion. So let's answer the questions, and then whoever wants to speak up, just feel free to share your thoughts on the approach or share your own approach, all right? So and before we do that, I just want to say a disclaimer. I've recorded the Anupama part of this session, so I usually avoid recording the discussion parts because I don't know how comfortable people are being recorded and shared, on YouTube. So you guys let me know. I'm gonna stop the recording now, and then if you guys are comfortable, I can record the discussion as well.